Hello everyone, today we are going to see a visual editorial for Doof Fires Brackets from Coder's Legacy conducted on Codechef. So the problem is in front of you and I'll put the link to the problem in the description if you want to read it from the contest page. So you can pause the video now and read the problem if you want. If you want to give the problem a try, you can do it now, else I'll proceed with the editorial. So we are given a string of opening and closing brackets and we are asked a lot of queries. In the ith query, the character appears at time ti and faces all the brackets from ti till the end of the string. So for example, if in a query ti is 4, then all brackets from 4 to 8 will be faced by the chef. We are asked to find the minimum index x such that the substring from ti to x contains a valid non-empty bracket subsequence. So for example, if ti is equal to 1, then x will be 3 because the substring 2 to 3 is a valid bracket sequence and it is the first such bracket sequence. So answer for this case is 3. So let's rephrase the problem. Given a string s and for multiple queries and index ti, we have to find the minimum index x such that the substring ti to x contains a valid non-empty bracket sequence, and if it does not exist, we have to print -1. Also note that since in our subsequence we need to have as many opening brackets as there are in the substring from ti to n, we cannot remove any opening brackets. So in fact we need to find a substring and not a subsequence. Okay, let's quickly discuss the brute force approach. In the brute force approach, for each query, you iterate from ti to n and find the first index at which you are able to form a balanced bracket sequence. So here is the code for the brute force approach. We use two variables opening and closing to keep track of the brackets. Then in each query, we iterate j from t to n, and if the current character is an opening bracket, we increment the variable opening, else we increment closing provided the opening bracket is not 0, because then that closing bracket will be a part of an invalid bracket sequence. So if we are able to find a j such that opening is equal to closing and provided it is not 0, then that index is our answer, else it is -1. So the time complexity of this approach is q into n, which will exceed the time limit. So how to optimize this? What we can do is we can pre-compute the answer for each and every possible index from 1 to n, and when we are given a query, we can just answer that query from our pre-computed array. So we initialize an array pre with -1, and in the end, pre of I would store the answer when the query is I. Now how to compute pre of I for a particular I? Let's consider the fifth index of the string s. If you are given a query with t as 5, then the answer would be 10 because the substring 5 to 10 forms a valid bracket sequence. So it seems that we should push opening brackets onto the stack and pop the opening brackets when you find a corresponding closing bracket. In fact, it would be better to push the indices rather than pushing the bracket itself, because the indices would be unique. Also, when you pop an index from the stack in the pre-array, for that index, you should set the value of the current closing brackets index. So for example, when you are at index 10, you will be popping 5 off the stack because the closing bracket at 10 is the corresponding closing bracket for the opening bracket at index 5. So you would set pre of 5 as 10. Here is what I mean more visually. Let's take one more query. What happens when Ti is equal to 3? Well, at index 3, we have a closing bracket and we do not have a corresponding opening bracket. The stack would be empty. Notice that the answer would just be the answer at pre of 5 because from 3 to 5 there is no valid bracket sequence. The next valid bracket sequence is from 5 to 10, like in the previous case. So for each closing bracket that occurs before a valid opening bracket, we need to set pre of that closing bracket to pre of that first valid opening bracket, which will be to the right of it. So for example, here we will set pre of 3 and pre of 4 to pre of 5, which is 10. So here is the code for it. Pre is our pre-computed array, S is our string, and we have taken a stack open to keep track of indices of opening brackets. We iterate from 1 to n, that is over all characters of the string, and if that character is an opening bracket, we push it onto the stack. We push its index onto the stack. Else, if it is a closing bracket and the stack is not empty, then we pop the index of the corresponding opening bracket from the stack and assign pre of index to I, that is the current closing brackets index. Now we need to assign pre of each closing brackets index to pre of the next valid opening brackets index. So what we can do is we can iterate in reverse from n minus 1 to 1 and assign pre of I as pre of I plus 1. In that way, all closing bracket indices will have the value at the next valid opening brackets indices. And then finally, to answer our queries, we just print the value of pre of t. So that was the code. Time complexity of this code is O of n plus q, n to build our pre-array and q to answer the queries. Finally, if you are interested, here is a full running example of our logic on a string. So that finally is our pre-array, which we will use to answer queries. So that's it for this video. I hope you enjoyed it. If you have some doubts or questions, please ask them in the comments.